When you first encounter a term like Poynting's theorem, it can sound pretty intimidating. It's a cornerstone of electromagnetic theory, and it's absolutely essential for answering a very practical question. When you have electric, or E, and magnetic, or H, fields, where does the energy actually go? The theorem itself is a mathematical expression, but its core concept is incredibly intuitive. It's simply the law of conservation of energy, applied to fields. Let's break down the intuition first before looking at the math. The big idea, an energy audit. At its heart, Poynting's theorem is an energy audit. You draw an imaginary box, your volume V, around anything you want to analyse, a resistor, an antenna, a wire, or just empty space. Poynting's theorem gives you the exact equation to balance the energy checkbook for that box. The fundamental question it answers is, where does all the power go? The analogy, the magical, leaky, flexible tank. Imagine your volume 5 is a magical, leaky, flexible water tank. Its walls are the surface S. You are an auditor. You stand outside and must account for every drop of water. Energy. What are the 4 and only 4 things that can happen to the water? Power. 1. Generation. P sub S. A magical spring inside the tank is creating new water. This is your source power. 2. Loss. P sub L. The tank's walls are made of a lossy material. As water flows, the material heats up, causing some water to evaporate as steam. This water is gone forever as heat. This is your power lost, or dissipated. 3. Flow. P sub O. The tank has leaks. Water is flowing through the walls to the outside world. This is your power flow. This water isn't lost, it's just moving somewhere else. 4. Storage. W sub M and W sub E. The tank is flexible. As you pump water in, the walls stretch, storing energy. This water isn't lost or gone, it's just being temporarily held. This is your stored energy. The conservation law is obvious. The amount of water created must equal the amount flowing out, plus the amount evaporated, plus the change in amount stored. This is Poynting's theorem. Now let's map these to the real concepts. Building the concepts one by one. First, the flow. The Poynting vector, S. This is the most important part. How do we measure the water flowing through the walls? Or P sub 0. This is done by the Poynting vector, S. The S vector is defined as the cross product of the E vector and the complex conjugate of the H vector. That is, S equals E vector cross H star vector. The core intuition is that the S vector is your flow meter. At any single point on the surface, this vector tells you the direction the power is flowing and the power density in watts per square meter. To get the total power flowing out, or P sub O, you must add up or integrate the flow S over the entire closed surface S. Second, the loss. Power dissipated, P sub L. This is the evaporation in our analogy. It's power that is lost as heat inside the volume. This is the classic Joule's law. The cause is conductivity, or sigma, and material losses, represented by epsilon, double prime, and mu double prime. To find the total loss, you add up, or integrate, all the tiny bits of heat generated everywhere inside the volume V. Third, the storage. Reactive energy. This is the flexible tank part. This energy is not lost, it's just borrowed and returned every AC cycle. W sub E is the electric energy, like in a capacitor. It's the energy stored in the electric field. The equation is W sub E equals epsilon divided by 4 times the integral over the volume V of the magnitude of the E vector squared, dV. W sub M is the magnetic energy, like in an inductor. It's the energy stored in the magnetic field. The equation is W sub M equals mu divided by 4 times the integral over the volume V of the magnitude of the H vector squared, dV. In an AC system, these two are in a constant dance. The term that represents this is 2 times J times omega, all multiplied by W sub M minus W sub E. This is the net reactive energy. The J tells us it's reactive power, out of phase with the real power. Fourth, the source. power from the source, P sub S. This is the magical spring inside the tank. It's any current source, J sub source, inside our volume that is generating power. The equation is P sub S equals negative 1/2 times the integral over the volume V of the dot product of the E vector and the complex conjugate of the J source vector, dV. The final audit, the full equation. Now we put it all together to balance the checkbook. Power generated equals power out plus power lost plus power stored. P sub S equals P sub O plus P sub L plus 2 times J times omega times W sub M minus W sub E. The power delivered by the sources is equal to the sum of the power transmitted through the surface, the power lost in the volume, and 2 omega times the net reactive energy stored in the volume. Poynting's theorem is simply the fundamental proof that energy is always accounted for. It gives us the exact names and formulas for every term in our energy audits.